What do elasticities look like in the real world? Let's look at a good that anyone who's ever driven a vehicle will be quite familiar with: gasoline. For some people, a rise in the price of gasoline won't change their behavior much. These people have to drive to work or school, and driving means stopping to buy gas every once in a while. No way around that. But others might be able to cut back on gasoline consumption in response to higher prices. They might carpool to work, or do a few errands all in one trip, rather than one at a time. Or maybe a family postpones their road trip until gas prices drop. So how much do people actually respond to changes in gas prices? That is, what is the price elasticity of demand for gas? It turns out that a lot of people have looked at data in an attempt to answer this question. And there's a lot of data to look at. Gas prices in the US have gone through huge swings over the past 40 years. And there's also a lot of variation in gas prices between countries. Gas prices in Europe are several times as high as in the US. In the US alone, there are over 100 studies which try to estimate the price elasticity of demand for gasoline. So what do they say? It turns out that the estimates of elasticity very much depend on the time frame we're talking about. In the near term, for months after the price of gas changes, the price elasticity of demand for gas is somewhere around 0.25. For every 1% increase in the price of gas, consumption falls by 0.25%. Put another way, for a 10% increase in price, demand falls by 2.5%. This is a relatively low elasticity, and it tells us that people are not very sensitive to changes in the price of gas in the short term. That's not that surprising. In the short term, people are stuck with whatever vehicles they have, whether they be gas-guzzling SUVs or more efficient hybrid vehicles. So the short-run price elasticity of demand is fairly small. Over a longer period of time, however, the price elasticity of demand for gas is estimated to be around 0.6. For every 1% increase in the price of gas, consumption falls by 0.6%. Or put another way, for a 10% increase in price, demand falls by 6%. When people have more time to respond to higher gas prices, they tend to buy more fuel-efficient vehicles, carpool more often, or use public transportation. All of these result in lower demand for gas. It's clear that the price of gas affects the demand for gas, both in the short term and the long term. But what about the effect of the price of gas on the demand for other goods? For example, when gas prices fall, do car sales fall? This is a question of cross-price elasticity. How responsive is demand for cars to a price increase in gas? Studies estimate that if the price of gas goes and stays up by 10%, the total number of vehicles owned goes down by less than 1% in the near term and about 2.5% in the longer term. These figures correspond roughly to cross-price elasticities of 0.1 and 0.25 respectively. So gas prices don't seem to have a huge effect on the decision to buy a car. Digging deeper into the data, however, we find that gas prices may not make much of a difference in the decision to buy a car, but they may help determine what kind of car to buy, or even what kinds of cars manufacturers are producing. Higher gas prices mean higher demand for more fuel-efficient vehicles. In the US, gas prices spiked in the 1970s and early 1980s. These higher prices had the long-term effect of making the US auto fleet a lot more fuel-efficient. Then, as gas prices dropped back down in the middle to late 1980s, so did the average fuel efficiency of US vehicles. These low gas prices lasted into the 90s and early 2000s and helped fuel an explosion in the sale of large, less efficient sports utility vehicles. And when gas prices rose again around 2005, what do you know? So did the average fuel efficiency of the cars on the road. Cross-price elasticity in action.